Hello everybody. Today I'm going to do a walkthrough of my term project for the blockchain course. For this final project, I've implemented a file storage system on blockchain. We have discussed earlier that storing files on blockchain is very expensive, both in terms of time and money. So my project uses a solution which is a combination of IPFS and Ethereum blockchain to store files on the blockchain in an efficient manner. And to overview the architecture of the project before I dive into the code, we take the image in the browser. The browser converts it into a buffer file. The buffered file is sent to IPFS, which is a P2P network, which stores our file and returns a hash value of that file. That hash value is then taken and stored in an Ethereum smart contract. So instead of storing our file, which is very expensive, we only store the hash on the Ethereum smart contract, and our application can again access the file by using this hash, which is stored on the smart contract. So to do a walkthrough of this code, this is my directory, which is the image directory. If you go to the source folder and the components, app.js is my main component here. So in app.js, as we can see, if we go to the render function, this is the main function. First of all, to start this application, I'll have to run certain commands. The detailed step-by-step instruction is given in the project README, in the project report. So let's get started. First of all, I want to compile my smart contracts, which I've written here, which is image.sol, which is the extension for Solidity. The smart contract has two functions, set and get. The set function is used to take the image hash and store it on the blockchain inside the smart contract. And the get function is used to read the image hash from the smart contract. So first of all, I would like to deploy these smart contracts onto my local blockchain. For that, I will run up my local blockchain on Ganache. So my local blockchain is up. Now what I want to do is I want to compile these smart contracts. So I'll run truffle compile. And after that, I'll run truffle migrate, which will put these smart contracts onto the blockchain. So my smart contracts have been put onto the blockchain, and I can finally start my application. So when I start my application, I'll use a command called Npm Run Start. And this will start the application on localhost 3000. It's going to take a minute to pop up. So as you can see here, we don't have an image by default. So what I'm going to do is I'm going to choose a new file from the system. And I'm going to click on submit. Now when I click on submit, a transaction goes through and I have my image over here. Now I just want to walk through the code once to show you how this transaction actually went through and what actually happened behind the scenes. So in our code inside of our main file, which is app.js, so when I upload the file here, my capture file function is run. What the capture file does is it takes the file, it converts it into the buffer and sets it on the local state. as a property called buffer. Now when I click the submit button here, this button, what happens is on submit click function is ran, and on submit click what it does is it takes the buffer, it sends the buffer over to IPFS, and IPFS returns an image hash. Now when the image hash is returned, we set that image hash, or we send it to our smart contract using a dot set method. So we send it the image hash, and as we know inside our contracts, this set function is expecting the image hash, so the image hash gets stored here, and when it does, we set the local state of the image hash to be that image hash, and our application, basically this image element, makes a call to Infura, which is the service we're using to access IPFS, and it takes the local image hash which was set on the state, and it displays that image. So that is the complete cycle of the application. Now if we want to change this, we can again go to choose file, select another photograph, and click on submit. Another transaction will go through, and we can confirm it. So that changes the file here. Now I also want to point out that our MetaMask is connected to the Ganache network here, as you can see. This is important, and the configuration steps are given in the project report. Moreover, this account with this much ether, it is the same account that is in Ganache, so we're properly connected to MetaMask and Ganache, and that was the entire workflow of the project. And I hope that it was understandable. One final thing I would like to walk through is the async load blockchain data. Basically, when our app starts up, these two functions are run, first of all, which is load web3 and load blockchain data. What load web3 does is it creates a web3 instance that is injected into MetaMask. And this is what allows us to communicate with the smart contract, which is placed on the Ethereum blockchain. And once we have this instance, this web3 instance right here, we have access to the accounts through web3.eth.get accounts. So we get access to accounts. We take the first account. We have access to the network data through get ID. And what we're doing in this function is we're saying if we have a network data, which will be true if the connection of MetaMask and Ganache is proper, we can access the contract that is deployed on our local blockchain through this by sending it the image.abi and the network data address. And we can get the contract on our client side. Then to get the image hash, which is stored on the contract, we just have to call the call method on the contract, and we will get the image hash. So that was another part of the cycle of the application. I hope the entire workflow is clear, and that will be all. Thank you very much.